So I think the hardest part about the word problems is you have to create your own picture that kind of correlates with what it's trying to say. So it says Matt is standing on top of a cliff that's 305 feet above a lake. The measurement of the angle of depression to the boat is 42 degrees. How far is the boat from the base? Okay. First thing first, whenever I think of angle of depression, I think of an upside down triangle. So I usually draw it dashed, and I'll explain why. It's kind of like, so I have this angle of depression because it's really outside of the triangle. So that's my angle of depression right here. And then when I'm drawing the actual scenario, so I have Matt. He's standing on the cliff. There's a lake here. There's a boat. Let me draw a little boat. Okay, the base of the cliff. So he's standing on the cliff. So I'll say this is the cliff, which is not really a cliff, but you all kind of get the idea. So that's Matt. He's standing on the cliff. The cliff is how high? How high is the cliff above the lake? So 305 feet go here. And the angle of depression is what? 42 degrees. So let me go ahead and erase. Oops. Okay, that didn't go the way I thought it would. Okay, right here. And that would be 42. 42 would have to go here. And we want to know how far is the boat from the base of the cliff. So where do you think I'm going to put that X? Does it go here? Does it go here? Where would I put it? On the bottom or on the hypotenuse? On the bottom, right? Base is the bottom. So we have our X here. Now what you need to know is that when you have a triangle is half of a rectangle. So I have my right angle here, but I also have a right angle here. So in relationship to this triangle, this 305, opposite sides of a rectangle are the same. So I could put that 305 over here too. So I'm going to put that 305 here too. And the X, even though, remember, opposite sides are congruent, that X can also be here because the distance from here to here is the same as the distance from here to the boat. So if I'm using my upside down triangle only, and I have to label opposite, adjacent, and hypotenuse, what would the X be? Is X adjacent or opposite of the angle of depression? This is my angle. It's adjacent, so I'm going to put ADJ there. And then the 305, what is that? Is that opposite or is that the hypotenuse?
Opposite.
Okay. What trig ratio uses opposite and adjacent? Tangent. So I have the tangent of 42 degrees equals opposite over adjacent. And I usually, when I taught geometry, I'd always have them make it a proportion. It's just optional. You don't have to do that. You're cross multiplying. You're multiplying this way and you're multiplying this way. So what I have is X times the tangent of 42 equals 305 times 1. Divide both sides by the tangent of 42. So pick up your calculators, type in 305 divided by tangent of 42. And we're going to go to the 10th place. Who got 338.7 feet? And that would be your answer. So again, the majority of your problems for 8-1 are word problems. Okay, so I think again, just trying to make a picture that kind of just, depicts what it's trying to described. Some of them get a little bit more complicated, but these first few are pretty basic. All right, let's look at example 9. I know my numbering is off because your packet, the example numbers are wrong, so I had to fix it. So look for this question. It says example 9, a ladder that is 20 feet long is leaning against the side of a building. If the angle formed between the ladder and the ground is 75 degrees, how far is the bottom of the ladder from the base of the building? So I'm going to draw myself a building. And then I have my ladder. So I draw my ladder. And it says the ladder is 20 feet. So this is my ladder. That ladder is 20 feet. And it's leaning against the side of the building. The angle formed between the ladder and the ground, not the ladder and the building, but the ladder and the ground. So that would be here, is 75. And they want us to know how far is the bottom of the ladder from the bottom of the building. So I would put my X here. All right, take a minute, see if you can solve that out. Figure out what trig ratio you're using. So what is the X? Is that opposite, adjacent, or hypotenuse? And what is that 20? Is that opposite or the hypotenuse? All right, what trig ratio uses adjacent and hypotenuse? All right, so we have the cosine of 75 degrees equals adjacent over hypotenuse. Again, put that over 1, cross multiply. And go ahead and solve that for X. So 1 times X is X, and then 20 times the cosine of 75 degrees. So type 20 times cosine 75. And you should get that it's 5.2 feet. Who had 5.2 feet? Okay. All right, go ahead and read the next example. See if you can draw your diagram. Your diagram doesn't have to look exactly like mine, but I'm going to give you a minute to try to work through that one by yourself. And the main thing is, are you using the right trig ratio? What happened? Oh, so you have to hit this button. That changes it to a decimal. The button above there. my diagram. So my X is over here. I don't know if you can see the X, but that's my X. So see if you can figure out what trig ratio you would use to find the height. All right, who used tangent? Okay, good. So the height is of the balloon would be opposite of where I'm standing. And if I'm 50 feet away, that's the adjacent side. So you can go ahead and put that over 1. Let's cross multiply. So x equals 50 times the tangent of 28 degrees. And that would be 26.6 feet. Anybody else have that answer? Any questions? Anything you need me to go back through? What do you all think? I mean, I know that this is all from geometry. 8.1 is just kind of a refresh. And then the rest of chapter 8 is new material, but 8.1 is just a review. All right, let's keep moving forward here. So we got a man is in the boat. So I'm going to draw my man in the boat. I literally have to draw the man in the boat. He's 175 feet away from something. So this is the little cliff. And the cliff is 200 feet. So this is the right triangle. But remember, for angle of depression is always opposite. So when I draw my angle of depression, I'm going to kind of like fill in the rest of my rectangle. This is that angle. So angle of depression is always outside of the triangle. If you look at that diagram that was in the previous page where it talks about angle of depression versus angle of elevation. But because a triangle, again, is half of a rectangle, that 200 can also be here, and the 175 can be here. Now, because I'm trying to find an angle, remember, for an angle, we have to use an inverse. Inverse for an angle. So in order to find an angle, you have to hit the second function key before you hit that trig key. So the 200 is opposite of that angle of depression, and the 175 is adjacent. So the tangent of theta equals opposite over adjacent, which means that theta is the inverse tangent of opposite over adjacent. So you can go ahead and type that in your calculator. Again, you have to use that inverse key.
You got a coffee maker again?
No, I went to the teacher reset room. They have one. And there's like, I need to buy my own. I'm gonna buy mine. I am. I also want to get a gamer chair. A nice, comfortable chair. They're not even as expensive as I thought they were. I thought they were like $200. Only like $90, $75. So I'm gonna get one. All right, so when you type it in, what did you all get? Anybody else get 48.8? Anybody need help typing it in? Okay. Now, this next one, there is a sentence that I need you to add. I have it highlighted in red. Go ahead and add that to the end of that question. So, Kelly is flying a kite that has an angle of elevation of 70 degrees. The string on the kite is 65 meters long, but you need to add that she is holding the string 3 feet above the ground. How? Yes. So she's not like laying on the ground trying to fly the kite. She's holding it 3 feet above the ground. So that sentence that I have in red, go ahead and write that in at the back. And I'm going to give you a second to try and draw your picture and work through that. And then we only have 2 more and we're finished for today. So you're just adding that sentence that I have in red, that Kelly is holding the string 3 feet above the ground. So she's not laying on the ground. The string is 3 feet above the ground. Have you all ever flown a kite? Do people still fly kites?
Wait, it's meters or feet? Because that says meters.
Oh, it should be feet. I'm sorry.
No, like, it says 65 meters.
Oh, so she's holding it. Oh, yeah, you're right. We got different units here. So why don't we change that to how many meters are in a feet? Is it? It's 3 meters in 1 foot.
No, 3 feet in 1 meter.
It's 3 feet.
Let's just make it 65.
So let's say she's holding it 9 meters above the ground then.
9 meters.
Wait, how many feet is 9 meters? It's 3 feet.
So 27 feet.
No. Okay, so 1 meter. Hold on.
Let's just do 1 meter above the ground.
There you go. Yeah, let's do that. That's funny. You say Kelly 27 feet tall. No, Kelly not that tall. She's a little kid. Okay, y'all. So I know for those of you that are confused, I did not realize that these had different units. So instead of 3 feet, can you change that to Kelly is holding the string 1 meter. Okay, that's what you need to add. She's holding it 1 meter above the ground. Sorry about that. Because we do not want to have to deal with different units. Okay, so back to the kite. Has anybody flown a kite before? I only flew a kite 1 time.
Like in 3rd grade.
All of my kites got stuck in a cage.
Like, do they still sell kites?
No.
Yeah.
No.
They sell like fancy ones.
Yeah.
I think I'm gonna fly a kite.
I like an airplane kite.
They
and then my
used
brother
to sell
would get-
like these really
Really?
cheap ones at Five Below that were made of like plastic that had the characters on it.
Oh,
Like Dora.
do they actually fly though?
They fly.
They just get stuck in trees somewhere.
Oh, okay.
They're a lot more durable.
Okay, anyway, sorry, that was my ADD. Okay, so she's holding a kite. The string of the kite is 65 meters. And remember, she's holding it 1 meter above, but that doesn't really come into play yet. So with that string, we have our right triangle. And the angle of elevation with that string is 70 degrees. So we're gonna put our 70 right here. Now remember, we're trying to figure out the height. So the height would be this distance, technically, from here all the way down here. 1 second, and then I'll answer it. So the first thing we're going to do is we're going to find X, but then because the string is 1 meter above, we have to add 1 to that. Okay, yes, Carmen. I just had to finish my sentence before I answer your question. Or was that Kimmy?
That was,
It was you, okay.
so is the angle
Okay.
of elevation always gonna be closest to the ground?
Yes.
Okay.
So go back to the little box.
Yeah.
Yes, the angle of elevation is on the ground and the angle of depression is above with the horizon. Because you have to think, Kelly is looking up, so that angle of elevation is going to be closest to her. All right, so the first thing you're going to do is find X. So the first thing you're solving for is this piece. But then we have to add to that 1, because from here to here is an additional meter. So what trig ratio am I going to use? Who says I'm using cosine? Who will use sine? Who will use tangent? All right, so let's look at this. The X, is that opposite, adjacent, or the hypotenuse? From Kelly. Opposite from Kelly. The 75, which is the kite string, is your hypotenuse. So it would be the sine of 70 degrees equals opposite over hypotenuse. So again, we're going to just cross multiply that. Just like so. So X equals 65 times the sine of 70 degrees. And what did you all get for that? 61? No decimal?
61.08 or 61.1, my bad.
Oh, okay. So is it 61 or 61.1?
61.1.
61.1, okay. So 61.1 feet, but that only gives us this distance. And remember, she's holding it 1 meter above the ground. So to figure out the actual total height, we would need to add that 1 meter. So the total height is 61.1 plus 1, which is 62.1 feet. Okay, I think these are pretty straightforward, but there is one that I think might be kind of difficult, and that's number, well, we could do 12 because 12 is that's quick, but 13 is the one that might take a little bit of time, or the next one. So let's look at number 13. I'm gonna let you all try to do that one by yourself. And then the next one, that one might take a little bit more time. So take a minute, try to draw out your picture. See what you come up with. So we got a water slide. That sounds like fun. It's 175 feet above the ground. And it's 200 feet long. What is the angle of depression to the bottom of the slide? I got 61. The water slide is 175 feet above the ground and it's 200 feet long. So 200 is the hypotenuse because that's the slide. You know, you go slide, you slide.
It says it's a straight.
Meaning that when it says it's like, I mean, can you slide straight across
I
that?
don't know. I
You
mean,
can.
slip and slides.
If the water's pushing you, but
That's
a whole
kind of
different problem.
weird. A slide, I think when it says straight slide, they're saying that it's not like a turning. It's just a
Okay.
straight, like you just go straight down. That's what it's trying to
See,
say.
I think there was an error in the.
In the question, you think then the book messed up. You're right. Yeah. So it's a straight slide, so it's 175 feet straight. So it doesn't curve and go twisty turny. It's just you just go straight down. You climb up and you just slide straight down. So it's 175 feet down. No, that's not where I put that 175. Sorry. It's 175 feet above the ground, but the slide itself is 200 feet long. So that's why you really have to read the question. So I'm gonna quit talking and let you all read. Let you all read and try to visualize it. Usually, whenever I do a word problem, like I always tell my students, I always read it the first time and I don't try to draw anything. I read it the first time, and then the second time I try to read it and picture it. Because if your picture is wrong, your work is going to be wrong.
My calculator keeps turning off. I think because it's like dark in here.
And those batteries are really hard. You got to take out 9 screws. So I usually just throw them away. Okay. So it's 175 feet above the ground. So this is the ground, right? Got the ground. So the height is 175 feet. But the slide itself is 200 feet long. What is the angle of depression? So remember, angle of depression is always outside of the triangle. So the angle of depression would be here. Going back to what we said, if you look at that box diagram on page 2 or 3, the angle of depression is always on the outside of the triangle, and it's always with the horizon. So I can also put that 175 over here. So what trig ratio am I using? Who says I'm using cosine? Who says sine? Who says tangent? So 175 is opposite of that angle. The 200 is my hypotenuse. So what trig ratio uses opposite and hypotenuse? Sine. So it would be the sine of theta equals 175 over 200. So theta equals the inverse sine of 175 over 200. All right, go ahead, type that in your calculator. And I put 61.0. Oh, it was just 61. Yeah, I didn't put what came after the zero. I'm assuming it was a little number. Okay, perfect. All right, did anyone else get that? I'm just curious, how many who had the right answer before I start working through it? Okay, so we're about 60% there. All right, go ahead and read. We're going to finish with this last one. We got one more and then we're done. I want you to read it. This one is a little tricky. Read it. Don't try to draw anything. Read it and then read it again. Okay, so we got a camera. So I'm going to just put a little camera. I'm just going to write camera because I'm not going to try to draw a camera. So a camera is a mountain on the wall 11 feet above the ground. So from here to the ground is 11 feet. So I'm gonna put 11 right here. And then the camera, what is the angle of depression that should be used if the camera is directed to a spot that's 5 feet above the floor and 10 feet from the wall? So it's 5 feet above the floor. So the camera is going to hit a spot that would be 5 feet. So from the spot that it hits right here is 5 feet above the ground. And it's 10 feet from the wall. So from here to here is 10 feet. So there is an actual triangle here though. And the triangle is here. That's the triangle. And we're trying to figure out the angle of depression, which would be right here. So what we need to figure out is we know that in this green triangle, I know that the distance from here to here is what? What's the distance from here to here? 10. The tricky part though is, how do we figure out this distance? Subtract the 5 from 11. And what is 11 minus 5? 6. So we know that that 10 is adjacent and 6 is opposite. So I'm going to use tangent. So tangent of theta equals 6 over 10, which means that theta is the inverse tangent of 6 over 10. So I got 30.9 degrees. Is it 30.99999 or did it round up to 30?
96337.
Yeah, so I wrote 31, yeah. And that would be your final answer.
If we kept it as a decimal on the test, would we get points off?
No.
Okay.
So on the actual test, which obviously I haven't looked at because it's not till like April 18th, but it does say where to round to. Yes, Onike? So you put tangent of 10 over 6, then you would not get the right answer. Because the angle of depression is going to be next to the camera. So it's like, how are we tilting the camera? So the angle of depression should be next to the camera.